Okay, hi guys. So this is a quick video on some revision of the atom. Right then, so this is chemical world number 3. And our learning outcome here is that students should be able to describe the model and structure of the atom. So a model can be like a diagram or a drawing of the atom, and the structure of it means how it's actually made. And we need to include terms. So the nucleus is one important term that we need to be able to include. The proton is another important term. Neutron and electron. Okay, so we also need to compare the mass and charge of protons, neutrons, and electrons. So by the end of this lesson, that's what we will have done. Right, then we're going to focus our revision by doing an exam question. So this is question 8 from a previous mock paper. And the picture below represents two models of the structure of the atom. I'm going to try and make this a little bit bigger. Okay, the picture below represents two models of the structure of an atom. So here on the left-hand side, we've got what is called the plum pudding model of the atom, and on the right-hand side, we've got the Bohr model of the atom, proposed by Niels Bohr. So these are just two models, just two different types of drawings to represent the atom. That's all that means. Now, part A is asking us what subatomic particle is represented by the yellow circles in figure 1. Okay, well, before we can answer that question, we need to go over a little bit of information. So first of all, atoms are incredibly tiny particles. We are all made of them, and all of the things that you can see and touch are made of atoms. So I'm made of atoms, and you're made of atoms, and this marker is made up of atoms. Now, one of the phrases used in that question is the subatomic particles. So subatomic particle means the particles that actually make up the atom. Because atoms, even though they are really small, they are composed of much smaller particles. Okay, we've got three particles that the atom is made up of. We've got the proton, electron, and neutron. And we need to be able to describe their location, mass, and charge. Now here on this side, I've got a very rough drawing of that diagram of the atom that we have there. So we're just going to have a look and fit and complete this diagram. So we've got a little blue dot in the center. I've got these are called orbits going around, and we've got some dots on those orbits. Now those dots represent electrons, and this is the Bohr model of the atom. So when you're doing this, you can fit two electrons. There's 1, 2, on what's called the first shell. On the second shell, you can fit up to 8 electrons. So here's 1, 2, 3, 4, 5, 6, 7, and finally 8. 2 electrons in the first shell, 8 electrons in the second shell. And now for this atom, for when we're completing this, you can fit 8 electrons in the third shell. But for this atom, for this question, we only have got 4. So we're going to put in those 4. 1, 2, 3, and 4 electrons in what's called the outer shell. So it's the shell furthest away from the center of the atom. Now, the center of the atom, that's a really important part. That's called the nucleus. Okay, and that word is part of our learning outcome. We need to know that the center of the atom is called the nucleus. And what hangs around in the center, so there's 2 different types of particles that hang around in the center. There's P for protons and N for neutrons. And we can fill this into our table now. So we've got our protons, electrons, and neutrons. So the location of the protons is in the nucleus. And the location of the neutron is also in the nucleus. So it's part of our table already done. Now we were talking earlier that these dots outside the nucleus represent electrons. And that's exactly the location of them. So the electron, we can say, is outside the nucleus. Or we can say in what's called the electron cloud. Either of those answers, whichever you find easier to remember, will do to answer that. Okay, now we're going to continue on. We're going to finish this table. The next thing that we need to do is compare our three particles in terms of mass. Now, protons are incredibly small, so we can't measure their mass in kilograms. We've got a different unit for them. We have a unit called AMU, atomic mass unit. And we give protons a mass of 1 AMU. That's like our standard unit. So 1 atomic mass unit for a proton. Neutrons have the exact same mass. They've got a mass of 1 AMU as well. Now electrons, they are much, much smaller. They're a tiny fraction of the mass of a proton. And in fact, that fraction is 1 divided by 1,836 AMU. Now, you don't need to remember that number. You just need to be able to compare their mass. You need to be able to say that protons and neutrons have got the same mass, and electrons have got a much smaller mass. Now, finally, to finish this table, our charge. Protons are positive. Electrons are negative. Neutrons are neutral. No charge. So plus sign for positive. Negative sign for electrons. And our neutrons are neutral. That means that they've got no charge whatsoever. Right then, we've got enough information to answer at least the first couple of parts of this question now. So the question is, what subatomic particle? So don't get confused by that. That just means, are we talking about protons, electrons, or neutrons? One of those three is represented by the yellow circles in figure 1. Okay, so we can see on those yellow circles, they've got a minus symbol or a negative symbol. Now, if we go back to our table, there's only one subatomic particle, an electron, that's got a negative symbol, a negative charge. So that will be the answer to that question. Now, for part B, what subatomic particle is represented by the plus symbol? Okay, so here's our plus symbols. We go back to our table. Okay, there's our positive symbol, and there's only one subatomic particle, our proton. It's got a positive symbol. So that's the answer to that part. And now name a subatomic particle that is found in the region represented by the large blue circle in figure 2. Okay, so there's a large blue circle. Now that large blue circle, remember, represents what we call the nucleus, the center of the atom. And there are two subatomic particles that are inside the nucleus. Protons, P for protons, N for neutrons. And we've also got that on our table, our location. Protons are in the nucleus, neutrons are in the nucleus. So to answer that question, we can either say protons or neutrons in here. Either of them. Now, you should, for part D, refer to page 79 of your Formula and Tables booklet when answering this question. Okay, so always have your trusty Formula and Tables booklet with you in the exam. If you're not given one in the exam, ask for one. And we are asked, to what group number of the periodic table does the atom shown in figure 2 belong? And we need to justify our answer. Right then. So here is our periodic table. I think I need to zoom out. Right then. So on our periodic table, and for this question, we are asked what group number, I'll go back to the question, what group number of the periodic table does the atom shown in figure 2 represent? So, bit of revision here again. On our periodic table, these are the group numbers, okay? There's 1, there's 2, 3, 4, 5, all the way up to 18. And they are the group numbers. So anything in group 1, okay, so we've got hydrogen, lithium, sodium, potassium, rubidium, okay, and it keeps on going. Anything in group 2, we've got beryllium, magnesium, calcium. So this question is asking us, we need to use that to figure out, well, what group is this atom in? Right then, so the first bit of information we need to know and understand is that the periodic table that's given in your Formula and Tables booklet, this one that I've got in front of us, there's one change that we have to make to it. And we want to actually ignore, okay, these groups, well, okay, 3, 4, 5, 6, 7, 8, 9, 10, and 11. We want to ignore those numbers completely. Because if you check on the periodic table in your book, you'll actually notice that they're not numbered. So we're going to use the same type of periodic table that's in our book. Now this means that once we ignore them, it's going to go from group 1, 2, and then over here we've got 3, 4, 5, 6, 7, and 8. Okay, now that's that bit done. Now what do these group numbers even represent? Well, anything in group 1 means that it has got 1 electron in its outer shell. Anything in group 2 has got 2 electrons in its outer shell. Anything in group 3 has got 3 electrons in its outer shell. So to answer this question, what we need to do is we need to look at our atom here and count how many electrons do we have in the outer shell. Well, we've got 1, 2, 3, 4 electrons in the outer shell. So this means that it is in group 4, okay? So it's either belonging to, it could be carbon or silicon, or any of these other atoms underneath group 4. Okay, so to answer the question, let's zoom in again. Okay, so to what group number of the periodic table does the atom shown in figure 2 belong? Okay, because it has got 4 electrons in its outer shell, it is in group 4. And that's the answer, and we've justified our answer. Justify means give a reason. So to answer that question again, it is in group 4 because it has got 4 electrons in its outer shell. Now that completes that question, but there's one other thing that I'm going to revise with you guys just before I let you go, because we also need to understand a little bit about the atomic number and the mass number that is on our periodic table. I'm going to go back here. Right then. Zoom out again. Okay, so for silicon here, chosen this atom, we've got a 14 up on top, and we're going to round this number down below, 28. I'm also going to clear a little bit of space on the board. Okay, silicon, Si, 14 up on top, 28 down below. Now that number up on top represents what is called the atomic number. And that is the number of protons in an atom. Sorry, I forgot to make myself big. Okay, silicon, number up on top, 14. That's the atomic number. That is telling us how many protons are in that atom. Now down below here is what's called the mass number. And this is the number of protons and neutrons combined. plus neutrons. Right then, so if we were to actually build this atom, we now know that we have to put in 14 protons. Okay, so to start off, you would, in the center of the nucleus, put our protons is equal to 14. The next step we need to do is we need to figure out how many neutrons we have by themselves. Well, we know that we have got 28 protons and neutrons. So we need to figure out, well, if we've got 14 protons, how many, or what would be the number of neutrons that would make up a number of 28? Well, it's going to be 14 plus what? Plus 14 equals 28. So now we've got the center, the nucleus of the atom made. Now the next step when we're building an atom is we need to put in that the number of protons, we need to figure out how many electrons we have. And the number of electrons is equal to the number of protons in a neutral atom. So this means if we have got 14 protons, it means that we're also going to put in 14 electrons. So here we've got 14 protons. Okay, so there's our first 2 electrons that we will put in. Then we put in 8 in the next shell. So there's 8 and 2 makes 10. And then 4 in the outer shell makes 14. So this atom in this question that we were just talking about is silicon. Okay, so there it is. As it happens, because we've got 4 electrons in the outer shell, and that number of electrons we've worked out, and we've made a silicon atom. Right then, so what do you need to do now next to help with your study and help with your revision? Okay. Right then, next, I want you to revise the atom in your book. Step 2, learn the table of the properties of the subatomic particles. So that's that table that I had up here. That's a really, really important table. And go to our learning outcome sheet and check off as you study. So what do I mean by this? Okay, so on my website, go to the study tab and learning outcomes. And here you'll find the study checklist. Do you see that there? And when you click the study checklist, you will find under Chemical World 3 exactly what you should be able to do. Okay, and tick them off as you go. So we have covered all of this today. I hope this helped, and best of luck with your revision.